Hello, this is Tim Sandle, and I'm back with you with another 5-minute video. Hopefully these are okay, and being the time that would traditionally be for pantomimes, unfortunately not with the coronavirus, I could say, what do you think of the show so far? But I won't. So with each of these videos I'm trying to think of something different, try and keep them fresh. And today I was feeling a little bit Dickensian, so I thought it might be interesting to look at the ghosts of Cleanrooms past. So I dug out my old original book of Cleanrooms, and in here are some of the issues that BPL had challenges with. And let's see what the historical archive tells us. Well, first of all, we got something about pressure differential, and this is important for cleanrooms because it prevents bad air from flowing into areas where we have good air. Now, the HVAC system that used to be in place at BPL used to have a series of air dampers that had to be set manually to get the required pressure differentials, and then there were very large pressure gauges on the walls that sterile operations people used to have to go around and record down manually the pressure at regular intervals. And then sometimes the bacteriology department, as it was then called, used to have to go around and blow smoke with little pencils to make sure the clean room was working properly. Now we have much more efficient HVAC systems with variable frequency drive motors, which can automatically make adjustments where there's a low pressure situation. We also had poor airflow in some areas. Bizarrely, there were some rooms with ceiling returns. The value of having low room extracts located down near floor level was not really understood until the 1990s, with the advent of things like computational fluid dynamics, where airflow patterns could be measured and tracked. And this helped to reduce the numbers of particles and bioburden reduction. Now, next thing that I can find in the old book of Cleanrooms is that, well, I know that cleaning and disinfection, washing down walls, floors and ceilings is a repetitive and tedious task. A few years ago, again back in the early 90s, BPL used to gas its clean rooms with formaldehyde. Now, it transpired that this was carcinogenic, so that had to go. And also, it wasn't particularly good at maintaining microbial control. And we have better control now with our tried and tested measures. However, we still recognise that the task takes time, and this is why we're investing in hydrogen peroxide vapour technology, and this will be applied particularly at outages and shutdowns, and I'll use a future video to talk about hydrogen peroxide technology. We also had, I read here, poor fabric. Now, there used to be things like epoxy coated cinder block and gypsum board surfaces, and these were prone to chipping, and they could wear down easily in high traffic areas, and they also required frequent repair, and the damaged surfaces would create particles and provide harbours for microorganisms to reside in. So we've invested heavily in more robust materials, in vinyl equivalents like polymer surfaces, which are easy to clean and chemical resistant. It's also possible these days to buy surfaces that are actually resistant to bioburden adhesion, and this is something that we should be looking at going forwards. We also have far more automation today. And automation first appeared in clean rooms with programmable logic controllers. And then for running autoclaves, that became to be more automated. And actually, we're less reliant upon autoclaves these days with single-use sterile disposable technologies, such as aseptic connectors. And this kind of technology is going to become far more common. And for those of you involved with Line 3 and who will be fortunate enough to be involved in future state Line 4, then you'll know that through the use of isolators we can automate more through computer technology and get far more reliable and consistent forms of contamination control. So what can we draw from these various stories from my old book of Cleanrooms? Well, aseptic processing technology continues to evolve and it gets better, and we can reduce human involvement, and wherever we can take out human involvement we reduce the fundamental contamination source, and we can also reduce variability. And we continue to invest in more isolators, automated freeze dryer loading, the VHP decontamination chamber, more aseptic ways to get stoppers into filling machines. And we'd like to have a look at as well things like automated machine disinfection after the setup activity, which will help us introduce sporicidal disinfection. And we remain open to your ideas about how we can make things better. We can always drive forward, so please talk to your managers or even drop me an email and we'll look into anything, any ideas you might have. So, I can hear bells in the distance. That means it's time for me to go, so hopefully you've enjoyed some of my old cleanroom lessons, and good luck with your shift. Till next time, see you. Take care. Bye.